Hey guys, welcome to the next lesson. Now, again, chapter 10 I think would be pretty difficult for e-learning. Maybe after probability we'll come back to some of it. But we're just going to do a whole lot of probability because um, it's definitely going to be on your test, standardized tests or ACT. And some of you might not see probability till Algebra 2, which might not be till senior year, so it could be a while. So we're going to spend, I think, the next 7 lessons talking about probability, and I'm breaking it down pretty basically. So I'm not throwing a bunch of different probability ideas together in one lesson, just a single idea usually. So I think it should be manageable, but again, when you throw everything together, it might be a little more difficult. So let's make sure we're taking notes and doing our homework every day. And so, probability lesson 1, we're going to be able to calculate theoretical probability. This is actually something we did in chapter 0 for those of us who were in my class um, in the first 2 weeks of school this year. So we only talked about this maybe 40 minutes. So I think it could be a good reminder. So theoretical probability, um, it's basically just a way to express how likely something will occur. It's calculated by dividing the number of favorable outcomes by the total number of possible outcomes. Okay. So maybe all that wordage sounds complicated, but I know you guys have done this before, and you guys will probably be like, what? Easiest lesson ever. Okay, so pause if you want to have time to write this down, but I'm going to keep going. And just a refresher, probability, you can express them as fractions, percents, decimals. I'm probably just going to be doing fractions. Okay, so your answers might look a little different than mine if you do decimals, and that's okay. But if we're talking about what probabilities mean, if your probability is a 1, it means it's going to happen, okay? So like if I asked you, where's my pen? And what color would be good? Let's go with magenta again. Okay, so if I ask you to flip a coin, what's the probability of getting a heads or a tails? Well, there's 2 possible outcomes, right? Heads or tails. And there's 2 possible outcomes. So these are the likely outcomes, these are total outcomes, which equals 1. Which means what's the probability that you flip a head or a tails when you flip a coin? It's 1. It means it's going to happen, right? I guess I know you guys are thinking, oh, it could land on its side, but let's not go into too depth like that. And then likely, if I said 0, so, I don't know. If I ask you in a deck of cards to pick out a card that has 17 on it or whatever, that's not possible because there's no 17 numbered card in the card deck. So that'd be impossible, okay? Right in the middle, 1/2, it's equally likely. So for instance, if I asked you what's probability of flipping a heads, if you flip a typical penny, well, there's one outcome where you could get a heads, and there's 2 possible outcomes, which means you're equally likely to get a heads or a tails, which makes sense. So you're equally likely to get a heads or to not get a heads. And then if you go closer to 1, so 3/4, it's a little more likely that your event will happen. If you go backwards, it's less likely. I think this is an idea that you guys understand. So moving on, your typical bag of different colored marbles. I really thought outside the box on this one. So a bag contains 4 marbles, 5 red marbles, and 6 green marbles. Find the following probability. Okay? And so again, this notation you're going to see used quite a bit. This stands for the probability of picking a blue. Okay? So this P and then in parentheses, that's your event. So probability of picking this event. So probability of picking a blue. And so theoretical probability is the total number of possible outcomes that we want. So the favorable outcomes, which there's 4 blue marbles, right? So there's 4 favorable outcomes that we want. And then we have to write how many total there are. So 4 plus 5 is 9, plus 6 is 15. So the probability that you select a blue out of that bag is 4 over 15. Let's do red. Again, the probability that you pick this event, or red. So, we see how many favorable outcomes there are. There are 5 favorable outcomes. And then the total number, well, that stays the same, it's still 15. Now here's the thing, we should simplify as much as possible. And so, you've been doing that with the slide problems. I think you guys are capable. If you see that number goes into both values, you can simplify, right? 5 goes into both of these. So I'm going to divide both by 5. 5 goes into 5 one time. 5 goes into 15 3 times. So the probability of selecting a red is 1 out of 3. Oh, what did I do? So I guess it just erased. That is annoying. We said 4 out of 15, and we said 1 out of 3. Sorry, you can rewind back to get that. It's my first time doing this, or I'm getting used to this on PowerPoint. So, and now one other thing is not picking something, okay? And so this is the probability of not picking a red. Well, you have to think, if I don't pick a red, what do you have to pick? Well, you can either pick a blue, because blue's not red, right? Or you could pick a green, because green's not blue, or green's not red either. So we're going to add those two together. 4 plus 6, which is 10, right? So there's 10 possible events where we don't pick red. So those are our favorable outcomes. And now the total number is still 15. Well, then you do your simplifying. 5 goes into both of them. Now let's pick a different color. It's getting hard to see. Which equals 2 over 3. Okay, so that's easy enough, right? We've talked about all of this in the past. These are your generic type problems. I mean, you're going to see them on standardized tests. It's kind of funny that they're all kind of the same. A bag containing marbles. Oh, well, I should have done this story problem about the probability of people leaving their pie pencils on the ground, because it was pretty high apparently. But Mr. Blurch has 30 blue pie pencils, 41 green pie pencils, and 29 orange pie pencils. Find the following probabilities. So again, before I go on, if you guys want to pause and try these on your own, you can, to check your work. Otherwise, you can listen to my very boring voice. So a probability of picking orange. Well, not sure what that is. We need to see how many favorable outcomes there are, or how many orange pencils there are. Well, there's 29 orange pencils over how many total. So we need to add 30 plus 41 plus 29. It comes out nicely. It's 100. So probability of getting an orange pencil, 29 out of 100. Probability of getting a blue pencil. Well, there's 30 blue pencils. There's still 100 total. Well, you can simplify that. 10 goes into both of them, so you can get 3 over 10. That's probability of getting a blue pencil. Well, now we got the probability of picking a not green pencil, okay? So you have to count all the favorable outcomes. So you have to look at the outcomes that aren't green. So 30 blue, because blue's not green, so 30. And then orange isn't green, so 30 plus 29 is 59 divided by 100. I don't think that can simplify. Okay, so those are our probabilities of those events. I think we have one final example. Yep. You will have one of these on your homework. Now, I showed this picture in case you're not familiar with a typical card deck, but there's typically 52 cards. it's broken into 4 suits. So, for instance, you got the clubs, you got the hearts, you got the spades, and you got the diamonds. And in each suit, there's 13 different cards. You have 2 through 10 numbered cards, and then you have a jack, queen, king, and ace. Okay, so there's 13 cards in each suit, and there's 4 suits, so 13 times 4 is 52 total cards. So first, probability of drawing a king. So we need to look. I need a different color. Ugh. Oh, I bet Sion would be cool. Oh, that's real cool. It's probably selecting a king. So we need to see how many kings are possible. Well, there's a king in each suit, right? 1, 2, 3, 4. So how many kings are possible? There's 4 total. Out of how many total cards? 52. Sion probably wasn't the best idea. Good thing I'm not an artist. We'll just go back to white. So 4 divided by... Sorry. So 4 goes into both of these. 4 goes into 4 once. 4 goes into 52 13 times. So probability of selecting a king would be 1 out of 13. Okay? Probability of selecting a number card. So this is going to require a little bit more thought. Let's see how many number cards are in one suit. You got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 in each suit, but there's 4 suits, right? So 9 times 4 gets you 36. So there's 36 total number cards in all of these. You could count them to verify that. Divided by 52. So I think 4 goes into both of these. 4 goes into 36 9 times. 4 goes into 52 13 times. So probability of drawing a number card would be 9 out of 13. So that's pretty likely. And now the probability of not a hearts. So again, that's the suit, hearts. So there's 13 cards there. So we need to figure out all of the cards that we could pick. Well, if it's not a heart, it could be a club. So there's 13 clubs. There's 13 spades. And there's 13 diamonds. So you add all those together, that gets you 39. But then you have to divide that by the total number of cards, which is 52. Does that simplify? I don't think so. Oh yeah, it does. 13 goes into both of these, so it gets you 3 over 4. So you have a 75% chance of not picking a hearts, or a 3 over 4 chance. Okay, so that's theoretical probability. Again, that's theoretical. Let's go back. Theoretical probability is, well, theoretical. We're going to talk about different types of probability, and it's important to pay attention to what type of probability they're asking for. Okay, so theoretical, I think that's the probability that we're used to figuring out and solving. But we're going to talk about other types like experimental. Okay. So with that, make sure you do the homework assignment by 4 p.m. tomorrow. And please make sure that you're turning in yesterday's assignment too. They shouldn't be that difficult. So make sure you stick with it.